Welcome to the channel. In this video, we are going to discuss inverse trigonometric functions, important problems for intermediate final examinations. See, your question is, if cos inverse of p by a plus cos inverse of q by b is equal to alpha, then prove that p square by a square minus 2pq by ab into cos alpha and plus q square by b square is equal to sine square alpha. See now how to prove this. Now what I am doing is here taking let cos inverse of p by a is equal to alpha. From this cos alpha is equal to p by a. Right, similarly cos inverse of so q by b is also is equal to, suppose here alpha is there already, so you take here suppose any a, suppose a you take, then it becomes cos a, right? So similarly here cos inverse of q by b is equal to, you take a capital B, from this cos b is equal to q by b. See now here the problem becomes what here? Now therefore cos inverse of p by a plus cos inverse of q by b is equal to alpha is given. Now what I am doing is, so here it becomes what? A plus b, this is a no? And here plus b is equal to alpha. Now we have cos A, cos B, operate cos on both sides. Cos of A plus B is equal to, this is cos alpha. Now cos of A plus B, we know the formula. What is that? Cos A into cos B and minus sin A into sin B, so which is equal to cos alpha. Cos alpha becomes cos alpha only. Here, this is as it is. And here cos A, cos B, you know. And sin A, how to write? See, cos A into cos B, writing as it is, minus. This is root over 1 minus cos square A writing. And into, this is root over 1 minus cos square B, writing like this. Then which is equal to cos alpha. Now, we know cos A, cos B values, substitute in this. So cos A is equal to P by A, cos A is equal to P by A, and cos B is equal to Q by B, minus. So here, this is root over, see what is a cos 1 minus cos square A, so 1 minus cos square A means 1 minus, so P by A whole square into root over 1 minus q by b whole square, which is equal to cos alpha. Now here, so pq by ab and minus, this becomes what? Root over 1 minus p square by a square into, so this is also 1 minus q square by b square. Why? Because root a into root b, we can write root of ab. So that's why here root of a into b. Then what we get here? So pq by ab is minus, so this is root over, so you can multiply this is, you can multiply with, so here 1 into, so p square by a square, otherwise you can write 1 minus p square by a square, so into 1 minus q square by b square. Otherwise you can do one thing, here this minus plus cos alpha, if you bring left hand side, so pq by ab minus cos alpha, send this is to the right side, so which is root over 1 minus p square by a square, so into 1 minus q square by b square. Like this also you can do. Then what we can do here, so squaring on both sides, suppose. If you do the squaring on both sides, then what happens? Here, PQ by AB minus cos alpha whole square, which is equal to, this is root over 1 minus P square by A square, so into 1 minus Q square by B square, so whole square here, squaring on both sides. So then what happens here? So here square and root gets cancelled here, and here this is like A minus B whole square, so which is A square, that is PQ by AB whole square, and minus, so 2 into A is what? PQ by AB, PQ by AB into cos alpha, and B square means what here? Cos alpha whole square. This is cos alpha whole square. So expanded like by using A minus B whole square. And here square root gets cancelled, no, which is equal to 1 minus, so P square by A square into 1 minus Q square by B square. So then what we can do, see here. So this is nothing but now, which implies P square Q square by A square B square, which is, and here minus, so 2PQ by AB cos alpha, this is, and plus here cos square alpha, and here which is equal to, right hand side is, if you multiply 1 into these two, if you multiply, so 1 into 1 minus Q square by B square, and again minus P square by A square, if you multiply, minus P square by A square, so into 1 minus Q square by B square. See now what happens, which implies, so P square Q square by A square B square, and minus 2PQ by AB into cos alpha, and here which is plus cos square alpha, so which is equal to, here if you multiply we get 1 minus Q square by B square, and here minus P square by A square, and minus into minus is plus, so P square Q square by A square B square. So these two are gets cancelled on both sides. Then here which is minus 2PQ by AB cos alpha, and plus cos square alpha is writing as 1 minus sin square alpha, and here right hand side we have 1 minus Q square by B square minus P square by A square. If you here left and right hand side, one also gets cancelled. Those terms if you bring into the right side, left side, now it becomes, so this is P square by A square, and here already minus 2PQ by AB cos alpha, and this minus Q square by B square also if you write in the left hand side, which becomes Q square by B square, and this minus sin square alpha if you write right side, it becomes plus sin square alpha. So then, so this is only we require to prove here, P square by A square minus 2PQ by AB cos alpha plus Q square by B square is equal to sin square alpha. So therefore, hence proved, like this we can prove the given problem.